from the Hong Kong Polytechnic University, Department of Computing. So today's topic will be modeling of social network services for deception detection. So let me just go through the agenda for today. First, I will have some introduction for social network sites, and I will have some problem statements. And then I will introduce some background information. After that, I will introduce my project methodology as well as implementation methods. And after that, I will mention some limitations. And lastly, will be the demonstration part. So first, the introduction part. What is social networking services, SNS? It is an online service platform that's specialized in constructing social relations among users by linking and grouping people. Web users, either an individual or a group, can create profiles on SNS sites. They can also create a list of other users, which they call friend list. They can also view and traverse lists of others. To facilitate communications in different social network sites, messaging services are also available in some of the sites. Recently, the SNS sites ahead are Facebook and Twitter. It is now a trend, at least in Hong Kong, to have SNS site profiles. As you can see, there are enormous number of people visiting SNS sites. For example, Facebook and Twitter, you can see that there are hundreds of millions of users and visitors going to SNS sites basically every day. However, the barriers to entry is bound to be low because these SNS sites will have to ensure that people can join the sites easily. As a result, it will be an easy target for spammers. They can just construct relations with other users, and they can send spam messages to them. So now for the problem statement part. In social networking sites, according to a survey, over 90% of web users received spam. And another survey showed that spam accounts actually take up 40% of the total. And the volume of spam messages can double over 6 months. It is also a point that spam filters for other communication means, for example email, may not work. Actually, the problem of spamming exists for a very, very long time. In the past, it used to be in the form of email. However, the spammers nowadays, they do not just need to generate a large list of users. They have to construct relationships with users. So in SNS sites, spammers must first create the relations. This situation different with email. And once the connection is established, spam messages can be sent. So spammers focus, we can see that it is shift from the contents of the message, for example email, to how to attract relations establishment. As a result, for anti-spam techniques, we need to switch our focus on filtering contents to identify if the request is from a spammer. So now for the scope and objectives for this project. As spam may differ from site to site based on the constructions and the type of relations of the social networking sites. The scope of this project will be restricted to Twitter. And these are some main objectives, including investigating the behavior of spammers on Twitter, developing a practical measure to represent their behavior, and to help to detect spammers. And of course, through this project, we can raise the awareness of spamming detection in social network sites as well. So now I'll introduce some background information. Twitter is created by Jack Dorsey in March 2006. It is designed as a micro-blogging platform. You can see that this is a profile. This is a profile on Twitter. Profiles are created by web users and are public by default. You can see that Alibo will be the owner of this account. How about the type of relations? We can see that these represent the relations on Twitter. The following sign here means that the user logged in is already following these users. It is a one-directional relationship, and after the login user presses the following button, he or she and Alibo will have a follower and following relationship. And communicating in Twitter mostly by tweets. Users can post tweets for followers to read. For example, these are the tweets. They are also public by default. There are also many functions that you can use on tweets. For example, the add function to call another user to reply to another user. The RT here stands for a retweet. And the hashtag here represents a trend that is some topic that's mostly discussed on Twitter. And some direct messages is also available as a service on Twitter. It is basically more or less the same with tweets. However, it is just a conversation between two users. So for the technology used in this project, I've used a Twitter API to make requests for Twitter data from the server. And I've used XAMPP with Apache and MySQL to create a web programming environment to retrieve data from the server. And for the web browser, I chose Firefox. And to implement algorithms and generate statistics, I use a software called Weka. Details will be explained later. So for the project methodology, we can see that this is the overall framework. I'll explain it part by part. So for the first part, users are divided into two types. The first type will be legitimate users. They register an Twitter account for the real purpose of communications. And of course, spammer accounts that spammers create accounts for promotional or malicious purposes. So, data for users are stored in the web server of Twitter. Therefore, requests must be sent to retrieve them from the server. So to achieve this, I used Twitter API. And data of user accounts will be collected through API calls. From the two sets of data here, we can see that from one set of account data, I will obtain features of behavior by observation. And after that, I will turn observations into programs. And lastly, I will test against another set of users to validate that the indicators are effective and useful. So for project implementation, the first stage will be data collection. It is achieved by making use of Twitter API calls. We can see an example here. You can see that it retrieved the latest 30 tweets of user Oliver Eland 861. Tweets are public by default. Remember, previously I've said that the focus of anti-spamming techniques need to shift from the contents of the spam to whether the request is from a spam user. However, as tweets are also public by default, analyzing them can increase the reliability of indicators as well as the system. So from observation, I have obtained 11 indicators based on my observation and previous papers. So these are categorized into two types. The first type will be account indicators that take account information to identify whether he or she is a spammer. So I will not explain each of them by detail, but you can see that, for example, the user description ratio. You can see that this is an account for a real user and this is for a spammer. In many cases, because spamming may consist of programs that generate spam messages automatically, and many of them actually are too lazy to fill in the explanations and many details of the account. You can see the difference. So by analyzing the user description of different profiles, we can maybe get some hints of whether this account belongs to a spammer. Another one will be a follower to following ratio. You can see that as spamming accounts need to attract attention and need to display the spam messages to as many users as possible. So they tend to follow a lot of users. However, legitimate users do not normally follow a spammer. So they will have many followings but not much follower. And I'll explain another category called tweets indicators. As I've mentioned that I'll also analyze tweets to increase the reliability of the indicators. The indicators include these, and I'll explain some of it. For example, URL ratio. Based on the structure of Twitter, each of the spam messages actually, many spam messages actually contain URLs. For example, you can see it. You can see the URL in different tweets. So, but normal users do not always include URLs in their tweets. So by analyzing their URL, you can get a hint of whether this account belongs to a spammer. Another will be similarity ratio. You can see in these three spam messages are actually very close to each other in terms of sentence structure or so. However, a normal user or a legitimate users do not use the same expression like over and over and over again. So by analyzing the similarity between tweets, we can also get a hint whether this account belongs to a spammer or not. So this will be the program framework for the project. You can see that there are many different files. They are written in HTML and PHP. So these parts of the program will be responsible for load and display. They are loaded into Firefox to display the results. And the API calls are centralized in parseUser.php and parseTweet.php because Twitter sets a limit on the maximum API calls that can be used in an hour. So I have to decrease the number of API calls being used. So these two are the files containing the API calls. And the 11 indicators will be calculated in these smaller programs. And eventually the results will be returned. Finally, go to the display and displayed in Firefox. So now go to the analysis part after the program is written. I've collected 800 user accounts from the Twitter server. 400 of them are legitimate users and 400 are spammers. They are manually classified. And then I will take the data, I will calculate the ratios based on the data I get from the Twitter server. And then I'll plot a scatter diagram like this. By analyzing the gap between the trend lines, you can see these two are the trend lines, between the trend lines of legitimate users as well as spammers, we can see the discriminative power of this factor. I will not explain the analysis for each indicator by detail, but at the end of the analysis, we can see different factors may have different discriminative power. You can also see a beyond expectations column here. It means that the results turned out from the analysis actually is beyond my expectations when I first give out the observations for Twitter. So now, going to the validation of indicators. Because I will have to make sure that the indicators that I mentioned, the 11 indicators, are effective and can actually reflect the behavior of spammers on Twitter. So I use a method called tenfold cross-validation, which is very suitable for a smaller data set. The data set is separated into 10 partitions of the same size. 9 partitions will be used as training sets, and 1 partition will be used for the testing set. This whole process will repeat 10 times until every partition is used as the testing set, and the results will be combined to give out the final result. So for this project, the tool used will be called the weaker toolkit. The input will be the ratios of the 800 users I extracted from the Twitter server, and the output will be the statistics. So there are different methods, different classification methods available in Weka, and these are the five methods that generate the highest accuracy. You can see that from the results of the Weka toolkit, simple logistics gets the highest accuracy of 97.5921. There's also many other methods that generate high accuracy. So now for the limitations of work. First, it will be the size of data sets and misclassification. Compared to hundreds of millions of users in Twitter, my 800 user set is relatively small, I would say. And because manual classification is used to identify whether the account is belonging to a spammer or not, misclassification may occur as humans are prone to errors. And the second limitation will be divergent statistics due to multiple accounts, as spamming is a problem existing for a very, very long time, and spammers are actually thinking of ways to escape from the eyes of Twitter and maybe many other users. So some spammers may create multiple spam accounts that follow each other. At the end, they may create a network that is similar to legitimate users, and this will be very hard to identify. The third limitation will be the lack of information for some users. You know that Twitter actually includes many different accounts, including those who don't even behave like a normal user. So, in the dataset I collected, some accounts have no followers, or even no tweets. These will affect not only the ratios being calculated, and also the accuracy of the indicators. And the fourth one will be spam classification can be subjective. It is a very, I would say, interesting limitations, and it is a limitation bound to be having in many projects, because different users may have different interests. Some users may sometimes find the promotional messages actually useful. For example, if I am very interested in fashion, I may want to keep an eye on the latest trends of some famous fashion brands. So if they send those messages to me, I may actually find it useful rather than find it spammy. So these are the important references for this project. Okay, you can see in here, this is the myindex.html that I write for displaying the results of different users. It also includes a tiny little bit of JavaScript that take user input in order to make this more user-friendly. And the result will be modeled by main.css. So now, let's wait no more. Let's start. So for the username, I type in a Twitter username, for example. For example, like this, I type in the username, and I will have to select the number of followers to be extracted for each turn. For example, 5. And then I will click the submit button. So now they will call different functions, as I mentioned in the program framework. They will make API calls. They will get the returned result from the API calls and then parse them. And then they will take the useful data from the returned result and calculate the ratios. The 11 indicators will be calculated in different ratios, or maybe standard deviation, or maybe mean. They will have different calculation methods, and eventually they will get their results returned from different layers to the display layers. You can see that the results of these users, AS movements, followers, are shown here. The current count will be 5. You can see this is the profile picture of this user, and you can also see the detail here. Different ratios that are the 11 indicators. So after showing different ratios for different users, I also written a part that helped me to generate some Weka code. As I've mentioned in the presentation, that I've used the Weka toolkit in order to analyze my results. However, it would be very troublesome and problematic if I just type it in the text editor, because it's prone to error. So I'll just take the ratios and generate them in a line like this. This will be the code for Weka. It is called ARFF. You can see in here that I've actually generated the username and their different ratios. The question mark at the beginning are to be replaced by the value either spammer or user, because as I've mentioned that I manually classified them into spammer and users, so the spammer and user value will be replaced for this question mark. So these will be the ARFF file that I used. I've removed the commands so you can see more clearly. In the beginning, I have to name this relation. For example, I name it spammer. and there are different attributes. You can see that these are actually the ratios and the 11 indicators that I've mentioned in my presentation, and the attribute nature will be the manually classified value of whether this account belongs to a spammer or to user. So the question marks are replaced by spammer and user. You can see there's just so many information. So now I will demonstrate the process of validating the indicators. So this is the interface of the Weka Explorer. I have imported the ARFF file that I've just shown into the Weka toolkit. You can see that these are distributions of spammer as well as user. Maybe you can also see that it's less than 400. Why? As I've mentioned in my limitations, that some accounts actually do not have followers, do not have followings, or do not have tweets. These are excluded from the calculation to increase the reliability. And you can also see the attributes here. So now we can go to the classification method of the data. You can see that I can choose cross-validation with fold number 10. That is the tenfold cross-validation method I mentioned. And you can also choose the classifying method that is used. And for this project, I used several different ones, but the one with highest accuracy will be simple logistics. So I will demonstrate it here. So you can see that simple logistics is chosen. And then the value to predict, there will be many to choose. And the one I chose will be the nature, because I have to predict whether the account belongs to a spammer or to a user. And then I can click start. This will take some time for the analysis. And the process of the analysis is shown clearly here. And you can also see here that they're carrying out different folds. And after the 10th fold, the results will be generated. You can see that. You can see in the summary that the correctly classified instances actually take up 97.5921%. That is 689 accounts. And the incorrectly classified instances are 17 of them, which takes up 2.4079%. There's also other indicators, other things that show the statistics of the analysis results. And this will be the confusion matrix. That is, this one will be the correctly identified spammers, and this one will be the correctly identified users. You can see these actually take up quite a large amount of the data set.